Alright, getting right into it. I want you to solve 8 to the 1 minus 2x equals 2. I want you to come up with two separate solution methods. Pause the video, unpause when you're ready to check your answers. Okay, so over here on the left, I use the idea that I can recognize 8 has a base of 2. It's 2 cubed. So 2 cubed to the 1 minus 2x equals 2. So now with my properties of exponents, I can distribute the 3. So 2 to the 3 minus 6x equals 2. So now since the bases are the same, I can drop the bases, and I know 3 minus 6x equals 1. Solve for x equals 1/3. Over on the right, so my other solution process was changing this to a log. There are many options with this. So I said 1 minus 2x equals log base 8 of 2. Now I started to solve for x, so I subtracted the log base 8 of 2x, and I subtracted log base 8 of 2 and I added 2x. Log base 8 of 2 is saying 8 to what power equals 2, so 8 to the 1/3 power equals 2, so log base 8 of 2 becomes 1/3. So 1 minus 1/3 is 2/3. 2/3 divided by 2 is 1/3. Very nice. Next one. I want you to graph this function. I want you to find the domain, the asymptote, and the intercepts. The function should include 2 accurate points at least. Pause the video, unpause when you're ready to check your work. Alright, so first, when I look at the function, I recognize that I'm going to have a horizontal shift to the left of 2. So that means my domain is going to be negative 2 to infinity, because the standard domain for a log graph is going to be 0 to infinity, and the vertical asymptote is going to be at x equals negative 2. Now to find the intercepts. So first I found the y-intercept by plugging in 0 for x. When I do that, I get an irrational number, 3 minus log base 3 of 2. I can type that into my calculator if I want. I chose to just leave it like that to get the exact answer. It's something between 2 and 3. I don't really care. Then I found the x-intercept. So to find the x-intercept, I plug in 0 for y, and I solve for x. When I do that, I end up with x equals 25. So my x-intercept is at 25, 0. So that's going to be off my graph. Alright, well, so now I need to come up with a couple of other points, because I said I want 2 points plotted accurately, and so far I can't really plot an irrational point that well, and the x-intercept is off the graph. So what do I know? Well, I know that if I look here at the x plus 2, if x plus 2 equals 1, then the entire log quantity is going to be 3 to what power equals 1, and that's going to be 0. If x plus 2 equals 3, then the entire log quantity is 3 to what power equals 3, which is 1. So that's the work that you see down here on the right. I first set x plus 2 equal to 1, and I solved for x. I got x equals negative 1, and then I plugged that back in. So if I plug that into my equation, I get y equals 3. So I know then that I had the point negative 1, 3. And down here, I set x plus 2 equal to 3, and I solved for x, and I got x equals 1. So then the y value is 2. So I know I have the point 1, 2. So those are the 2 points that I can find. And so that's what you see that I've plotted on the curve, and then my graph is going to look like this. Next, find the domain, the asymptote, and the intercepts for y equals 3 to the negative x plus 3, and then minus 2. Pause the video, unpause when you're ready to check your work. Alright, so here the first thing I notice is that I have a vertical shift of down 2, which means my horizontal asymptote, which is normally at y equals 0, is now at y equals negative 2. The domain is going to be all real numbers, because that's the domain for every exponential function, and that does not change here. There's nothing that I cannot plug in for x. Domain is all real numbers. So finding the x-intercept and the y-intercept. So to find the y-intercept, I plugged in 0 for x, and I got the point 0, 25. So again, that's going to be off of my graph. It's going to be somewhere up above the graph. To find the y-intercept, I plugged in 0 for y, and I solved for x, and I got x equals 3 minus log base 3 of 2, so the x-intercept is 3 minus log base 3 of 2, comma 0. Again, that's an irrational number. You may notice at this point that those are the same but opposite of what we got for the previous problem. That's because these two functions are inverses of each other. So if I don't recognize that, then I can do some work to find a couple of other points that I can plot accurately, but basically I know that it's going to be the inverse of the 2 points that I found on the previous problem. My thought process, though, to find those points is that I know if this negative x plus 3 equals 0, it's really easy for me to evaluate, and if the negative x plus 3 equals 1, it's really easy for me to evaluate. So that's how I came up with the points 2, 1, and 3, negative 1. Again, had I recognized from the beginning that these functions are inverses, I could have just flipped the x and y values from the previous problem. So now I plot the points, I graph the asymptote, and I draw my curve. Next two. So here I want you to just find the domain of each of the following. So pause the video and find the domain, and unpause when you're ready to check your work. I will give you a hint for the second one. You are going to need to use your properties of, or your solution solving methods for rational inequalities. So pause the video. Okay, so if we look at the one on the left here, or I'm sorry, the one on the top, log base 2 of 3 minus 4x, well, what do we care about to find the domain? We know that what we take a log of has to be greater than 0. So I set 3 minus 4x greater than 0, solve for x, I get x is less than 3/4, therefore my domain is negative infinity to 3/4. On the second one, f of x equals log base 2 of x minus 1 over x plus 2. So we start out the same way, x minus 1 over x plus 2 is greater than 0. This is a rational inequality. We do not multiply both sides by x plus 2. We need to find our critical values, which is where we set the numerator equal to 0 and solve for x, and we set the denominator equal to 0 and solve for x. It's already factored for me in this case, so I just get x equals 1 and x equals negative 2. Then I create my test intervals. So I cover the entire domain of x values, stopping and starting at the critical values. So negative infinity to negative 2, negative 2 to 1, 1 to infinity. Pick test values within those intervals to test in the inequality. So if I plug in negative 3 to my inequality up here, and if I plug in 0, and if I plug in 2, which intervals make the inequality true? And the first and the third make the inequality true, therefore my domain is negative infinity to negative 2 and 1 to infinity. Next one, I want you to expand this log using your properties of logs. Pause the video, unpause when you're ready to check your work. Alright, so I did this in 2 steps. You probably could have done it in 1. So first I recognize that I have here multiplication, and then this is obviously division. So I can separate this into the natural log of x plus the natural log of the square root of 3x minus 1 minus the natural log of the quantity x plus 2 cubed. Now the natural log of the square root of 3x minus 1, I can treat that as an exponent of 1/2, and I bring that down in front. So I end up with the natural log of x plus 1/2 times the natural log of 3x minus 1, and then minus 3 times the natural log of x plus 2. Next one. I want you to evaluate 5 to the log base 5 of 6 plus log base 5 of 7. Pause the video, unpause when you're ready to check your work. Alright, so here first combine the logs in the exponent using our properties of logs. Since I have log base 5 of 6 plus log base 5 of 7, I can make that log base 5 of 6 times 7. 6 times 7 is 42, so now I have 5 to the log base 5 of 42. But from my properties of logs, if I have an exponential raised to a log of the same base, then whatever I'm taking the log of is my answer. Last one. Log of 7 minus x minus log of 3x plus 2 equals 1. To solve this, pause the video, unpause when you're ready to check your work. Alright, so we should end up with negative 13 over 31 equals x. How do we get to that? Well, first we want to combine the logs on the left using division. They are subtracted, so I can make that log of 7 minus x over 3x plus 2 equals 1. Now I turn it into an exponential. Since it was common log, it's base 10. So 7 minus x over 3x plus 2 equals 10. Solve the equation, multiply both sides by 3x plus 2. Combine like terms, and I end up with x equals negative 13 over 31. Now we do have to check for extraneous solutions. So I need to make sure if I plug that back into the original equation, am I taking the log of a negative? And in the first term here, because it's subtraction, that's going to actually make the log positive because it'll have 7 plus 13 over 31. And then in the second term, 3 times negative 13 over 31 is still less than 2. So that will still be positive. So that's the end of the extra practice.